Okay, let's just talk a little bit more about 5.6 generators and motors. Now, the classic motor that we use, or the classic generator, is a loop of wire. Well, actually it's many loops of wire, and then we have a magnetic field, north-south, and we have a magnetic field that flows. Remember, the magnetic field goes from north to south. And the thing about most electric motors is they're designed, most electric motors generators are actually designed by, the basic design was by a guy called Nikola Tesla. He's probably the world's greatest electrical engineer ever. But most generators will act as motors. Most motors will actually act as generators. In fact, during the 70s and 80s, the hippies up in the Coromentals, they used to get old washing machines, take the washing machine motor out, to hook it up to a little Pelton wheel and a water wheel, and would generate about a quarter of horsepower, about 200 watts of electricity, quite happily all day long. So that was just using a standard washing machine motor. So most motors can act as generators, most generators can act as motors. And we get a classic example. If you've been to the Tower of Terror over in Australia, what they do is they put in a car, they've got a linear motor, which is basically one of these which has been stretched out. When they fire that thing, they have north-south, north-south, they put lots of generation, they put current through here, and this will shoot up about 120 metres in the air. And when they fire that, that acts as a motor. And it basically uses as much electricity as Melbourne for 3 seconds. Because it's a linear electromagnetic motor. Once it gets to the top, it stops. So what this motor does is it turns this into kinetic energy. As it hits the hill, it turns the kinetic energy into potential energy. When it gets to the top, it's all potential energy. Then it slides down, the potential energy turns back into kinetic energy. It comes back in. And on the Tower of Terror in Dreamworld, when it comes back, this acts as a generator. And they actually recover something like 97% of the electricity. They stick it back in a capacitor bank. Otherwise, the power bill for this would be horrible. So most motors can be used as generators. Most generator designs can be used as motors in a pinch. So normally it depends. Normally what we'll do is we'll try and put positive onto one side and negative onto the other. And then this will rotate. But the trouble, of course, is we will actually put a set of brushes on here. So as this rotates around, when this flips over, this side will always stay positive, this side will always stay negative, no matter what it does. So this side's positive. So these brushes, when this flips over, it now touches here, this side's positive, this side's negative, flips over, this side's positive, this side's negative. So this is called a commutator. And so that's how we can stick. So we basically stick DC power into a motor. You can actually stick AC in now, you get AC induction motors, but your basic motors are DC motor. Or if you have your loop of wire and you're spinning it around as a generator, the power output is like this. And you get an AC wave. Now the thing about AC, well, basically back in the day, there was a big amount of argument. Do you want electricity in AC or do you want it in DC? Nikola Tesla, who we just mentioned this before, advocated AC power transmission. So it goes positive, negative, positive, negative, positive, negative. Edison wanted DC. So if this is 0, this is up to 230 volts, he wanted DC power transmission. And in fact, Edison was so vehement that AC was incredibly dangerous that he demonstrated this by electrocuting an elephant. He hooked it up to an AC supply and killed it. and then took film footage of this and showed it in all the cinemas around America and showing the dangers of AC. But the reason why AC really won out in the end is AC has lower transmission losses, so if you stick AC down a power line you get less losses as a rule, though when we transmit electricity across the Cook Strait it's in DC, but everywhere else in New Zealand we transmit it AC. And when you stick it through transformers, the power has to be AC when it goes into the transformer. If it's DC, transformers do not work. So in the end, we decided AC is the way to go, and just about all of the major power transmission nowadays is done AC. And then when the electricity gets to your home to, say, run a television or run a computer, whatever, it then gets converted into DC to run your electronics, because most basic electronics work better as DC. But so, as a general rule, for basic motors we stick in DC, and if we turn it to generator we get AC out, but there's things we can do about that. So anyway, motors, generators, 90% of the time, the difference between a motor and a generator is if you stick electricity in and get motion out, it's a motor. If you spin the thing and you get electricity out, then it's a generator. Cool.